So again, Jeff Mamber, our Chief Executive Officer, sends his apologies. He was called to San Diego to meet with one of our customers this weekend, and so he asked me to kind of step in his stead. My name is Rob Alexander. I am the Center Operations Manager for Nanoracks. What we are is a commercial company that does commercial space research, specifically on the International Space Station. We are not a contractor. What we have a Space Act agreement wherein NASA provides us up mass, down mass, and crew time, and we find customers and we get their research on the ISS. So we've had a lot of success with this model so far. In 5 years, we've had over 230 experiments going up to the ISS and returning. And we've been able to keep the cost to the consumer down significantly. So when talking about deep space exploration, I'm going to go ahead and use a quote that I used the other night from Stella Chachkova, who's written several books and articles on commercial space and the commercialization of the industry. And she feels that deep space exploration, the asteroids and Mars, are a potentially huge market. We just need to figure out how to use it. Now, I found it prescient that the previous discussion talked about the two cultures and the divide, and they specifically said that early exploration is going to need a larger entity, and that we wouldn't be able to do it on a purely commercial basis. Now, with Mars 1, we may be proven wrong there, but Mars 1 would be, if it were able to get the funding that it needs, it would end up becoming that larger entity. So the discussion I would like to phrase with the success that Nanoracks has had on the International Space Station, with ourselves and other new space companies, we're starting to be profitable by conducting commercial activities in low Earth orbit. And we are all trying to make a buck off of this. And so we are searching for new market opportunities, not just Nanoracks, but when you look at the NanoSatisfy, Planet Labs, the other companies that we've been working with, there's an interest there in the market, and we're looking for what is the next step. The International Space Station is only going to be around for so much longer. So for our companies to continue on, we need to be ready to take that next step. So the way I decided to frame the discussion this morning is we want to get to Mars within the next 10 years. Can what my company, Nanoracks' capabilities, competencies, and our business model provide an economic boost to Mars exploration? Can we make a contribution? So the concept of the Nanorack, and I'm going to be very brief with this, is first of all, we get a PowerPoint that doesn't cut on you in the middle of the presentation. We've had limited success with that. What we've done is we started out very small. Those of you who were here on Thursday night, I mentioned that we started out in a U-Haul locker. We started out in a very small space, making space hardware on Highway 3, driving it over to NASA, having it launched and returned. Our first mission control center, or payload control center, was the couch at the front of that U-Haul locker. For a while, I was the only flight controller in the world working from the couch. Since then, things have changed. But what we started with were a couple of, we call platforms, just drawers, for lack of a better term, inside the Space Station Express rack. They're on the GEM. They've been moved back and forth in the lab. Our customers were intended to fit their experiment in a cube-like box, and I'm sorry I don't have one right now. We're in the middle of moving to bigger offices. We've graduated from the U-Haul to a larger office, and now we're getting an even larger office as we're victims of our own success there. But the concept was, instead of the way NASA was doing things and reworking everything around an experiment and having it go through 20 or 30 different panels to see if it could be accepted and get funding from NASA and then have everything work around that experiment, we said, well, this is our cube. You can put your experiment in the cube. It's got a USB port. It provides power data capability. Put your experiment in the cube. Give us a check for $60,000 and we will apply your experiment and we will get the data back. We kind of simplified things. Our job was to get the cube over to NASA, make sure there wasn't anything in there that was unsafe for the crew, and communicate and get the data back. So that's how we started, just internally with the International Space Station. And we turned a profit. $60,000 is a pittance to get an experiment on the International Space Station. Now you can expand these, you can pay a little extra money, have a larger experiment. If you're an educational institution, we charge half price, $30,000 for a high school to get their experiment on the International Space Station. So we had some very strong success. So I think for use in a Mars transit vehicle, we can use this existing concept inside the vehicle itself, and it could be utilized during the Martian phase itself, not the Marshall phase. Autocorrect got me on that one. So the advantages here that a Martian flight can have that would be competitive with an ISS mission is that it's a long duration mission, and it will be crew tended. Yes, we are crew tended on the ISS, but this would be a continuous crew tending throughout. And then we have multiple gravity environments. The ability to go from microgravity to the thrust of the maneuvers to 1/3 gravity and back provides new opportunities for research, because right now we do have a centrifuge on the ISS that provides moon and Martian gravity, but the space and the data and the power capability on our centrifuge is very limited. This opens up new prospects. Disadvantages, though, with the transit time and the conjunction status, is that we have command and data limitations. Getting the data back from Mars is going to be a little bit more of a chore, and it's going to take some data planning. One of our most successful products is mixture tubes. And Mariel, can you do me a favor and grab the mixture tube out of my computer bag up here? Mariel's one of our payload engineers, and she decided to join us this morning. And yes, I know, my bag is as messy as my car. So. Very simple concept here. Silicon tube. You mix it in with you put separate chemicals, biological agents in the tube, send it up, crew member unclamps it at a specific time, mixes it up, They can activate it at one point. Let's say you've got some bacteria you want to feed, planarian worms. You activate it. After a certain amount of time, you can put a fixative, deactivate it. This is a lot of what we do for education. We've done had a lot of success. You can load up a good bit of these at a nice economic rate. This is a $15,000 experiment right here. This is a sample. I mean, it's dihydrogen monoxide with color agents, water with food coloring. But this is something that could easily be utilized on a Mars mission, various different phases, something that can be done commercially and give access to STEM education, which is what we use these for the most part. You know, have school kids make mixture tubes, send them to Mars and back. Another market that's been talked about since the late 90s and has now come to fruition is protein crystal growth. We had success on the ISS last year. You see Chris Hadfield using a microscope to take pictures of some protein crystals that we grew on orbit. Unfortunately, protein crystals do tend to degrade after 60 days unless we get a better temperature regulation. But growth in Martian gravity provides other possibilities for larger growth with more stability. Instead of trying to have them grow against Earth gravity, they're going up against a lower level of gravity, and but they don't have the free reign of microgravity. So I think what we're going to see here is in Martian gravity, we're going to have a little bit smaller growth than what we do in microgravity, but they're going to be more stable, easily transported, could be brought back to Earth, or can be used for cancer research and cancer research on Mars itself. You know, sometime, I remember the old Boeing ads, it's about life on Earth. There you go. We do, like I mentioned, educational experiments. We've got, these are pictures from an actual module made by high school students. Ferrofluids, we've got plant growth chambers. You can't really tell on the lower left, that's a mini robot, and crystal growth. Now, these experiments were created, the concept were all created by high school students. And so, you know, this is a paying customer that we've got that is started out with one module about 4 years ago. I think we've got 5 of their modules on now. Meryl, I'm looking at you because you've been in the control center a little bit more than I have. Yeah, 5. So Valley Christian High School from the Silicon Valley, gives you an idea where the money's coming from, has been doing commercial research. If the opportunity is there for commercial research on an early mission, somebody's going to want to pay for that opportunity to go, even if they're going to pay to say, well, we were on that mission, we were on that first mission. If the opportunity is there, we can continue to use this model and lower the cost, then it's going to happen. Now, that's how we started out, was with internal modules. But our biggest market that we've come to find out is CubeSats. With this here is a picture of the Nanoracks CubeSat Deployer. It's a set of 8 deployers, silos, I think is what we're moving to call them now. We've been calling them tubes, but we're calling them silos now. With up to 6 cube units worth of satellites that have been deployed out of the GEM block. Actually, reasonably simple concept, spring-loaded deployment. The hard part is getting the command up to the space station, so we've had to partner with JAXA on this, and they actually commanded from their center in Tsukuba, Japan. This is a picture of it as it was being built on orbit. Koichi Wakata did that. And this is from the first, this is from the first round of CubeSat deployments. Now what's important here in this picture is, I call this the historical CubeSats. If you look, that first CubeSat right there at the beginning was built by university students from Peru. That is the first satellite ever built in Peru. The second CubeSat, the 2U CubeSat, was built in a U-Haul storage locker. See a pattern here. It's built by Nanosatisfy in a storage locker in the San Francisco area and was deployed off the ISS. They provided access to their satellite to their customers using Arduino-based technology. The next satellite is SkyCube, another commercial customer. And the last two satellites are the first satellites ever built and launched, both by university students from the nation of Lithuania. So, yeah, so the opportunity is there. I mean, getting a CubeSat deployment is a little bit higher cost, but the opportunity, once the opportunity to presented itself, the market showed up too. I'm going to take a little commercial break here, and this is the deployer in action. What you're going to see here are two satellites that are for Earth observations, built by Planet Labs, another San Francisco-based company. They're a little bit larger. They're 3 cube sizes in length. And they eventually turn back towards the Earth. They've got a telescope and a camera, and they are currently selling those images to commercial customers. So they are our largest.
To the ISS.
What's that?
They are not tethered to the ISS.
They are not tethered to the ISS. Once they're, in fact, we shoot them out at 1 meter per second, and we come at a trajectory that's computed so that there's no way they can recontact with the ISS. They are free-flying satellites.
What sort of lifetime do they have?
What's that?
What sort of lifetime do they have before they?
They have about 8 months, 8 months to a year, based on what we've seen so far. And so a lot of these are very simple satellites. UAPsat, the Peruvian ones, just basically beam the transmission, hello from UAPsat. They got connected with ham radio operators around the world, were able to receive it. It was kind of proof that they could do it. So a lot of these are very simple. The Argisats are a little more complex. They've gotten a good business response. So now that brings us to the question, let's go back to Mars here for a second. In deep space, is there a market for CubeSats in deep space? They would allow for more research beyond the Van Allen belts and at a reduced cost. There's really, we really have a limit on deep space research because of the launch costs. And on a human mission to Mars, or we can put a deployer on the vehicle and deploy these CubeSats at specific times. They could also be deployed in Martian orbit, which would be helpful. Imagine a constellation of satellites taking Martian observations on a more regular basis. With the wealth of data we've gotten from Mars Observer, You put out a constellation of CubeSats giving us data. We're going to have a treasure trove of information that will aid in exploration. However, these are CubeSats. They are small satellites. They're using small transmitters that, and the low transmitter power would limit the amount of time and data that the CubeSat could provide. So during transit, if we were to deploy a CubeSat, it would probably need to communicate with the transit vehicle as a bent pipe to get the data back to Earth. Transit vehicle would act as a relay. That limits the amount of time you're going to get data, because as it separates and continues to separate, it's eventually going to leave the transmit area. Larger satellites up to 70 kilograms might provide better capability, and we are working on providing that deployment capability off of the ISS. But that's something that needs to be investigated. Next product is the Nanoracks external platform. This is a platform that's going to go on the GEM Exposed facility later this year, or early next year. I bet early next year. Not sure what the pool is on SpaceX 5. It's currently being built by Astrium and is actually in the late rounds of testing right now. And it'll allow for up to 9 exposed payloads on orbit. And our particular unit provides power to 5 of them, 4 of them can be unpowered. I think this is a good potential market here. Like I said, about the deep space exploration and deep space research, our opportunities have been limited. Putting one of these, and these are actual photos of the unit here, putting one of these or several of these on the outside of on the transit vehicle could provide a good income stream. And they could also be used, I mentioned the Dove satellites, putting a constellation of Dove satellites. You could also put Martian observation equipment on this platform. It's using existing technology, simple to construct, simple to install, and could be used. Another nice thing about it is you can swap out experiments using an airlock. If you have a robotic arm and small airlock on the vehicle, you bring it in, have the crew swap out experiments, put it back out. So you've got the capability for multiple experiments in a small amount of space. And another beauty of it is you could stick it on the exterior of a Martian habitat and provide data that way, so you get measurements, get science on the Martian surface. So, to summarize what I've talked about, and I'd like to go ahead and have questions and have a discussion on this. I feel that the infrastructure is in place for commercial research on a Mars mission. The market is really an unknown right now. We really haven't really had our first deep space Mars research commercial customer yet. That piece of history has not happened. Now Mars One is working that, and we will have it on the Mars One 2018 lander, but that decision hasn't been made yet. So what I expect is customers for early flights may be pretty limited. I mean, people are, the amount of investment, the skin in the game that people are going to want to put in may be limited until we have proof of a concept. But I think it's going to pick up for later missions. Like I said the other night, once people see what can be done in deep space, what can be done beyond Earth orbit, somebody's going to find an interest and find a way to make a buck off of it. And with that, I'd like to take questions and start discussion. Yes, ma'am, you were first.
You said that the power for transmitting data is limited. At Mars, would you be able to arrange to use the Mars orbiter transmission capability?
Yes,
Is
we
it
could.
already fully committed?
That's, okay, so the Mars orbiter capability, that's already fully committed? That's a very good question.
Is it already committed?
Oh, is it already committed? I really don't know the answer to that question. One of our biggest limitations for getting data back from the ISS happens to be the TDRS satellite, because it's committed, for those of you who don't know, it's not just committed to the International Space Station and the shuttle earlier, but it also has to provide service to the Hubble. So we do, it's not really competing for data bandwidth, but there's a limit of bandwidth there. Yesterday I saw a research project that used CubeSats they wanted to use CubeSats for they called it a global positioning system. I'm not sure that's the right term, but set them out around Mars to provide data relays, and that's a possibility. But as far as using the existing resources, I think whatever mission that we do in the next 10 years, we are going to use any resource we can, and if that means getting the current the Mars satellites and getting their capability to provide data capability, I bet you it'll happen. Yes, sir.
Can you provide capability to put different surface materials on the outside of the CubeSat, like for an LDEF type experiment?
Yes. The question was, can we put different materials on a CubeSat for long duration exposed facility type experiment? You can put that on a CubeSat. Unfortunately, CubeSats don't always return. They're gonna burn up, or in deep space, they're gonna just keep going. So those types of experiments are better for the exposed platform that I was talking
We
about.
wouldn't need it to return.
What's that?
We wouldn't need it to return, but we might have to put different surfaces on different CubeSats.
Okay, and yes, and the answer is yes. You can put different surfaces on different CubeSats. One of our limitations, and is with the CubeSat Deployer. I'm calling it a limitation for lack of a better term, but one of our biggest headaches is that the CubeSats, even though we launch them up on a cargo vehicle, have the deployer assembled on orbit by the crew, the CubeSats never leave their silos. But we have to ensure NASA that they are safe, and that whatever materials are in there are not explosive, carcinogenic, anything like that. I think there's a potential with the Mars type mission if you set the deployer outside of the crew cabin upon launch, you don't worry about it. You don't have those concerns.
You can't have a single experimenter can purchase different CubeSats and say, put a series in orbit.
Yes, you can put a series in orbit, yes. And so, so if you're talking about a series of different material sciences experiments on CubeSats that you can put in orbit, that is definitely possible and can be done.
Any work with, I'm sorry.
Yes.
Any work with Dragon Lab?
Does it work with Dragon Lab?
Yeah.
Not quite familiar with Dragon Lab.
It's a SpaceX Dragon that's designed to be pretty much a standalone laboratory platform.
Okay.
Could
well,
take humans or it'd be standalone.
we are in continuous talks with SpaceX.
Okay.
And unfortunately, as much business development as I do, I've not been part of those talks.
Okay.
I suspect we will be working with Dragon Lab. We're a commercial company. We're willing to go take any ride that's available to us. And,
That has both in and outside, both in the trunk.
Yes.
And the trunk won't come back, but the stuff in the capsule will.
okay, and that would, you know, that would be a big opportunity for us, and I know that our business team has been in talks with SpaceX, amongst other companies. We're working with a lot of, so the International Space Station is not the only game in town.
Oh, sure.
And with Mars One and with these other groups heading out into deep space, the market's going to get bigger. And like you said, we just need to figure out how to use it. I had a question on the on this side here at the back. You, sir?
Yeah, I was curious, your opinion was on using lasers for the data transmission to, or the planetary resources.
Yes. Lasers for data transmission. I'm actually personally think it's a good idea if we can have a proof of concept. I'm not sure how much people who are investing in CubeSats or other items are going to want to entrust their data and their commercial work to laser communication until it's proven. This is the reality of commercial space. You're going to get a couple types of customers. Some of them are going to be researchers who are just finding a way to get their experiment on orbit, and that's the majority of our customers right now. The next round is going to be people who are doing a for-profit venture, and they're going to want to do what's proven. I know that the concept, and I know we've shown it can work. Whether or not it can work on a larger scale and be more effective than deep space needs to be seen. Okay, you've been raising your hand a couple times.
Could two CubeSats be attached to a tether and then be used to test artificial gravity?
Can 2 CubeSats be attached to a tether and be used to test for artificial gravity? The answer is yes, and I believe we're going to be deploying that experiment later on next year. So, you, sir.
Do you make the body of your experiments out of aluminum, titanium?
We, the experiments, the internal cubes are usually aluminum. We've had several that have been 3D printed before, and you know, they as long as they can meet safety standards, that's just kind of academic. Whether they can be, you know, carbon fiber material, as long as they meet safety standards, as long as they're not going to harm the crew when the crew touches them. No, I'm saying that's important, you know, especially on a Mars mission. That's going to be even more important. We want to get the crew there safely in order to actually accomplish the mission. Yes, sir.
NASA has expressed interest in using ISS more and more as a commercial platform. And
Yes,
yeah,
thank you to NASA for that.
And yeah, the rules that they set out seem to be very restrictive in terms of intellectual property and so on, and what you can and cannot do. Can you, since you're the guys who are actually doing it, give us a brief overview on what NASA does and does not allow within its regulatory structure right now for commercial operations?
Okay, and the question is intellectual property rights. For instance, and what we have in our Space Act agreement, and this what if you go back and look at the International Space University report on commercialization of the ISS in 1999, it said probably that the two biggest obstacles to commercialization of the ISS are intellectual property rights and launch costs. And with our Space Act agreement, we've been able to retain the intellectual property rights for our customers. Okay? So NASA does not retain NASA actually never sees the results of the experiments that are conducted. NASA is given proprietary information on what's in the experiment, mainly for safety purposes. and for crew training purposes. But as far as the results of the experiment, we only report to NASA what our customer wants us to report to NASA. And quite a number of them want their results made public because that's how they get follow-on funding. So, but according to our Space Act agreement, we are allowed to retain the intellectual property and maintain that safe for our customers.
Why is this still an issue then? Why do we still keep hearing that people don't want to go on that platform because they're afraid of losing their intellectual property rights?
Well, because
Is it just that you have a specific ad hoc agreement that doesn't apply universally? Does NASA need to make a blanket?
well, yes, we do. Well, and that is the reality of it. We have a special Space Act agreement that we were able to negotiate politically. Now, there will be other companies that will have similar privileges in the very near future. Gotta remember that the demand that NASA had for 10 years was that NASA's providing the service. This is a NASA vehicle, NASA launch. NASA deserves the intellectual property. So there's a major change in culture, and we had to bridge the two cultures. See what I did there? And
A bridge which is not yet complete is what
it's not yet complete, correct. For a Mars mission and for the next step, we have the opportunity to start from scratch, as it were, even though that most likely the launching state will be the United States, we can still, having Mars being considered res communist, considered high seas, we've got more room to work with to make intellectual property belong to the customer. I think there's more potential there. It may be a NASA vehicle, but NASA can't claim that part of Mars as its property. The U.S. government can't claim it as its property. So I think there's an open door on interplanetary research, asteroid research, deep space research. I think there's an open door to pushing the issue back where it belongs, where the intellectual property belongs to the researcher and not to the government. Yes, sir.
So far, you're kind of restricted to the CubeSat model and what you can do with rats. If you had to start over again on a Mars expedition, what would you consider to be the best bang for the buck form factor?
Okay.
If you were the one setting the standard.
Okay, so the question was that we've constrained ourselves to the CubeSat model and the Cube model. If we were to start over again, fresh start, Mars mission, what would I do, or what would we? I mean, my answer is going to be really disappointing here, because my answer is I will do whatever the customer needs me to do. So if they need a larger platform, if they need more than just a cube available, then we're going to expand it out. I suspect that may be the case for a Mars mission, but that's what we do. That's how we make our money. We do develop new capabilities with our new customer base, and as far as the bang for the buck, like I said, I think the best opportunity is with exposed platforms, because that provides continuous data and it's already out there. The exposed facility that we have, you don't need to keep, you can, and with actually any of our platforms, you can expand your experiment to fit within the size and power capabilities that we have. I mean, you can use up our whole platform if you want. that is a possibility. So our existing infrastructure can be used. But if we need to develop something new to get us a customer to go to Mars, we'll do it. You had a question, sir?
Yeah, did you say that Nanoracks had secured a payload spot on the Mars 1 2018 lander? Or did I misunderstand you?
Yeah, what we've negotiated with BOSS is that we are helping find commercial researchers, and if any of our existing customers, if we connect them and they choose to go on the Mars lander, that we will get a commission. And I'm trying to push BOSS into letting us put one of our facilities on the lander itself, and that, you know, without getting into too much detail, he's a little concerned about opening up a new negotiation with Lockheed and Nanoracks and making that work. So we are working with Mars One on that, but we are not, we don't have a dedicated platform on it. I would like to see that, but not yet.
Have you had any success in locating a commercial researcher? Not that you can tell us.
Not that I could talk to you about right now. Why, you interested? Let me make an aside here. The beauty of what's making commercial research work, and that what will work for the Mars mission, is that, like I said, I kind of explained that to get it. In the past, if you wanted to do research on the space station, you had to go to NASA, you had to have a paper drawn up and reviewed by a board, then it had to go to a safety board, then it had to go to the project management board, then it had to go back to a research board, and they had to choose which research they wanted to have. The beauty that I've seen in commercial research, I call it the green approval process. If you bring the green, you're approved to fly. And that's opened up a lot of doors, and that's why we've had so many experiments go through Nanoracks, including NASA experiments. NASA is one of our customers. It's not only a partner; it's one of our customers. They've had to get a piece of equipment, an experiment on the ISS faster. They've done it through Nanoracks. So, yes, ma'am.
Obviously, there's a volume limit, but you can stack them, but is there a weight limit?
Is there a weight limit to it? On the CubeSats, yes, for trajectory deployment reasons. For the internal volume, no. We try and keep it to 1.3 kilograms per cube unit, but we've gone over that before, and we've been able to manage to do it. So it's, you know, we don't want to overload our cargo vehicle. We don't want to, we have to work with NASA for them to provide space and on the vehicle, and we have to work with NASA for them to provide the services. So it really is a partnership. And if we show up with a 200 kilogram mass, which we've done before, it requires a little bit of patience on our part and a lot of work on NASA's part to get us on. But they do it. They do it. Yes.
Yeah, last week or it was the weekend before, I went to New Space. They had the 3D printer that was going on up to the ISS.
Yes.
And I also talked a few times about some people working on the Red Dragon, and last I heard, they had about 1.5 tons that was not specified yet that may be available for Nanorack to use.
Yes. So there's space on the Red Dragon for Nanoracks.
Yeah, that's what it sounded like. I mean, they were looking around if somebody else wanted to add something.
Okay, well, we'll pursue that. I appreciate the tip.
Red Dragon is going, should be going.
Okay. Any other questions? We're just about out of time. yes, ma'am.
What about including in your experiment a live animal?
Live animals, like I said, we've had planarian worms in these things. We've had, but as far as something on the rodent size level, there's other companies, other capabilities being built for the ISS, and we tend to, Paragon is developing a rodent enclosure. We can do it, but we're gonna raise the price on you. I'm just gonna be, it's gonna require a lot of work on our part, and it's gonna be a little more costly. All right, thank you everybody, and appreciate the opportunity to talk. What's that?
Do they have to be self-contained?
Do they have to be
If you're
self-contained?
doing rodents and stuff?
Rodents, yes, they do. You can't have mice and guinea pigs flying around unabated.
Yeah. I meant, do they have to be airtight too?
Airtight? No. But the fecal matter has to be contained.
Yeah.